Hello and welcome. I am Kaivalya Apte and this is the GeekNarrator. If you are building applications, especially microservices or distributed systems, you know that managing how your data structures and APIs change over time, what we call as schema evolution, is such a tricky problem, probably one of the trickiest problems. And if you get it wrong, you have broken integrations, you have painful rollbacks, and even data corruption. So in this video, we are going to explore what do we mean by schema? Why is it a crucial component? How do you go about managing schema efficiently? What are the current techniques? What are the current problems? And how Protobuf can be an ideal schema definition language. And when you combine it with Buf, which makes Protobuf really powerful, you can get amazing benefits when it comes to schema management. Before we get started, if you like this video, please don't forget to hit the like button and also subscribe to the channel. Please don't forget to check the links I have added in the description. These are really important resources from Buf's website. They have added amazing resources when it comes to schema management, understanding their amazing tool set and products. Also, thanks to Buf for sponsoring this video. Let's understand what we exactly mean by schema. So schema is basically blueprint for your data. It defines a structure of your data, what fields go in, like user ID, email ID, other important fields, other important metadata for your customers, and so on. And then it also defines the data types, which means if it's a Boolean, if it's a date, if it's a string, and many data types. And then since there are multiple fields, it also defines and connects these different pieces with relations. How different fields are connected, what is the relation between them, what are certain rules that must be followed, and so on. And all of it basically creates a contract between different components of your system that needs to be maintained, otherwise things may break. For example, you have a producer producing schema. For example, you have a producer which produces an event into a Kafka topic, and then there is a consumer. It takes the event, parses it, and it tries to understand what this event is about. But what if the producer just changes data and the schema and the structure of it? Consumers won't be able to understand the event. Even if it does, it may not understand in the same manner the producer meant. So it means there are certain problems. Either your consumption will break, some other parts of application would break, or there might be data inconsistencies, which indirectly impacts your business. Which means without clear, well-defined schemas, you have a ton of problems. You have miscommunication, producers, consumers, callers, and servers. All these need proper contracts. If the contract is broken, it doesn't work. There is data inconsistency, integration nightmares. You integrate so many different components, bring all the data together to make sense out of what's going on in different parts of your business. And if the schema is broken, there might be data quality issues, data inconsistency, data corruption, even things may not just work, and so many different problems. So trust me, have a solid schema management process. Now, while the need for schemas is clear, managing them effectively has traditionally been really challenging. Let's look at some common problems, especially with formats like JSON and Avro. These are solid things, right? It works, but then there are certain limitations and certain problems that you may face in production environments. Now, the general problems that we typically see when proper schema management process isn't followed, or your project is really complex, is first of all, you have schema drift. So you have documented certain schema, everyone tries to agree, but when your producer or your data is basically function of a runtime, you may have schema changes. Someone just deploys something and produces an event from a feature branch, and it gets registered as a new schema. Consumer does not understand what's going on, and it breaks. So schema drift, as in what's flowing through your pipelines, what's flowing in your RPC, may not adhere to what's there in the documentation, in the central registry. So schema drift is a problem. Lack of versioning, right? If you don't have proper versioning of your schemas, you may not know what version each consumer may be able to accept, what version is being produced, and so on. So you need good versioning system for your schemas as well. Accidental breaking changes, this is so common. I have also done that. I've also faced it. It's not really easy to understand if a change is going to break something, if a change is backward compatible, forward compatible, or not. So developers might, while doing their feature work, while adding more capabilities into your products, they may add some fields, they may remove some fields, they may change some structure. They may not even know that, some consumer may be having problem with this schema. So having a good mechanism to catch all these problems right before they are sent to production, to runtime, I think it's a powerful thing, and it's a must-have in modern applications. When you don't have tooling in place, when you don't have safeguards in place, you have to rely on communication, which means you have to kind of coordinate with the teams who are responsible for consuming data. If you want to change something, you have to do the stakeholder management. You have to coordinate effort, right? You have to make sure that everyone is aware that the version or the thing is going to be changed. So it's a problem. Ensuring all teams know that this change is compatible with whatever they're doing is a tricky thing and prone to all sorts of errors. It also basically hits your productivity because you have to do all this work and you always have to do the guesswork. It's a painful process. It's not really useful. And then if you don't have tooling, I think it adds up to it. If you don't have proper linting, if you don't have consistent formatting, if you don't have a breaking change detector, which is a game changer when it comes to schema evolution, I think it's always a tricky business. You are missing something, you're doing a guesswork, you're coordinating, you're putting a lot of efforts, but there are better tools available that we are going to talk about today. Now let's talk about JSON and Avro as the schema languages, right? The way you pass your data. Now, while JSON is great for data interchange because it's human readable, it lacks a built-in schema mechanism, right? You send a JSON blob and the receiver hopes it's what they expect. JSON schema exists to define JSON structures, and it's pretty verbose. Not always consistently adopted because people may use different libraries, people may have different validation rules, and so on. It's pretty much free form. And you have to also duplicate all the validation logic in producers and consumer code bases. And evolution, when you have so many copies and so many redundant logic, it's mostly error prone and manual. So there's no inherent way when it comes to JSON structure to tell you that it's backward compatible or not. Similarly, Apache Avro, it's way better than having JSON. It's a great step up when we talk about JSON. It's binary format with schema defined in JSON. You have .avsc files where you provide your Avro schemas, and schemas can be embedded within the messages, within the data, or managed via a central schema registry like Confluent Schema Registry or Glue and so on. It has good support for schema evolution, but when you use something like Avro with Confluent Schema Registry, the validation or the making sure that you're sending the right schema is on the client side. It has to do the heavy lifting, and there are things which are the function of runtime, and it may go wrong, and it's a problem. That's the reason Avro is more useful when it comes to big data pipelines and so on, but not really in RPC, and it's a problem. So you need something better. The core issue is that without a robust framework, schemas become an afterthought and leading to friction and instability and lack of productivity and impacting your business. So with this, let's talk about the recommended way, which is Protobuf. Now, Protobuf is a good choice and a solid choice for schema language, right? Especially when it gets paired with the right tooling such as Buf. Now, you define your data structures and service interfaces in simple proto files. As you can see, this is a sample user proto file, and it helps you define the request response and the service definition along with the data structure. Similarly, you can define your schema and related services in simple proto files. Protobuf provides you strong type safety, which means data types are explicit and no more ambiguity. It is efficient and compact as it serializes to a binary format, and it's way more efficient because the payload size is really small and it is suitable for high throughput, low latency applications, especially when compared with JSON-based schema definitions and payload definitions. Protobuf is designed with backward and forward compatibility in mind. You can add new fields, deprecate old ones, rename fields, some caveats, and without breaking existing services, of course, if you follow certain rules. You also have code generation. The Protobuf compiler can generate data access classes and service stubs in various programming languages. Most of the popular ones are covered: Java, Python, Go, C#, Ruby, etc. Historically, while Protobuf itself is really powerful, managing so many proto files at scale, ensuring consistency, preventing breaking changes across teams, and imagine tens and hundreds of teams, and handling dependencies could still be challenging. And this is precisely where Buf comes into the picture. Now let's talk about Buf and its ecosystem. Buf is a suite of tools that is built ground up to make Protobuf development robust, efficient, and developer-friendly. It addresses historical pain points and provides comprehensive and reliable ecosystem. There are three main components that I would like to draw your attention to: the Buf CLI, the Buf Schema Registry, and Buf Stream. The Buf CLI, it provides commands for linting, formatting, detecting breaking changes, and compiling, also generating code, and so on. The Buf Schema Registry is a centralized version control registry for your proto files, just like Git for your code, and more importantly, act as a single source of truth for all your data contracts, which means no more inconsistency and no more redundant validation logic, just one central place that seamlessly interacts and integrates with the CLI. So whatever you need, you can do using the CLI locally before it hits production, which means that no more breaking changes. You can validate your changes locally with your registry. There's just one source of truth, and these are some of the benefits. Third component, which is also very important, is Buf Stream. And this is specifically for teams using event streaming, because Buf Stream is a Kafka-compatible message queue. Its key differentiator is the direct integration with BSR for schema enforcement at the broker level, not at the client level, at the broker level, which makes it really easy. This means messages that don't conform to a defined Protobuf schema can be rejected before they can hit the production system, which means it helps you avoid any breaking changes, avoid customer impact. Together, Buf CLI, BSR, and Buf Stream create a powerful workflow that brings reliability and developer joy into schema-driven development. Now, let's summarize quickly the advantages of using Buf, and then I'll show you a quick demo using a simple application. Now, reliable schema evolution. The Buf breaking command helps you catch bugs, catch breaking changes before you impact anything, which is great. BSR provides you immutable versioning. You have consistency across the board. Everything has the single source of truth, that is the registry. The validation takes place at the broker level if you use Buf Stream. And you have amazing integration between the CLI and the BSR. You have simplified dependency management. The BSR allows your Protobuf modules to depend on other modules, which means less redundancy and more dependency. And overall, it improves developer productivity because you can build things locally using Buf build command. You have streamlined code generation, consistency in that as well, using Buf generate command, I'll show you in a bit, and remote plugin execution on the BSR as well. which means you also spend less time debugging issues and incidents, whatever happens with the breaking change, because you can do it before it goes to production. It integrates really well with CI/CD, which means you can do whatever you did locally in the CI/CD pipeline. So it can flag any changes that may be breaking, compatibility. You can automate checks and schema publishing in your CI/CD pipeline. So everything is controlled centrally. Overall, you reduce errors, increase stability, and reduce customer outages, which is really important for your business. Now, demo time. All right, let me quickly show you what I have here. First of all, let me go to the Buf repository. So as you can see, I have already signed up. I have an org, I have a user, and so on. Now I'll go to my terminal. Of course, I have a Buf CLI configured, and you might have to install it. I think on Mac, this command works. You can use brew install, and I won't run it because I already have it. Now what I can do is Buf login. So this is the command which I can use to log into the BSR. So as you can see, it redirects me to this. I'll approve it and go back here. I'm logged in. Okay. Now, if you see, I have a user proto file here. I've already defined it, and let's see how it looks like. So it basically has package definition, it has a user, a model, a request response, and the service. Very typical proto file. Now I can basically, if I go back to my main, I have a Buf YAML file, and it looks like this. So it refers to a repository under my username, and some dependencies that I might need, and the linting rules and how it is going to check for breaking changes and so on. Okay, now let's try to run lint commands. There are no errors, otherwise it will show me if there are some errors. And I'll also format. So this is the formatted output. Now I can basically just push my changes, and there's no repository, so I have to create a repository here. So I'll just create one, let's say user service, and I'll create a repository. Now as you can see, like GitHub does, it also shows you how you can log in and then just run Buf push. So I've already logged in, so I'll just run Buf push, and yes, I just committed, it has pushed my changes. And now if we reload, you see that the user service is created. It has some request response, the proto file. It shows you the proto file, and it exactly matches what I defined locally. Now what I can do is I can also run a command of breaking, because now I have my user service. Whenever I make some change, I can run this command to verify that is it a breaking change. So okay, so when I run this command, there's no change. Of course, I didn't do anything, so there is no breaking change, which is good. Now let's do some changes. Okay, now I'll go to user service v1 proto, and then I'll just try to add a dependency. Okay, now this is the dependency. I added a new field as well. Now this is not a breaking change, so ideally this should not have a problem. Now one thing I did show you was Buf YAML. This is the dependency I've already added. Otherwise I would have required to add the Google API's dependency, but I already had it, so we don't have to add it again. Now if I run Buf breaking, because I've changed the proto file, again it's not a breaking change. I can push it again. Okay, pushed another change, and if you see, I can go to the commits. I can see that 2 changes were done. This commit has this added and a new field added. It shows you everything for your schema like Git does. It will also show you the code, and as you can see, this field is added now, so everything good. Now what I want to do is let's add a let's add a breaking change. Now I will just do something, use a service, and probably I'll just, let's say, remove or just rename something, I don't know, email ID, right? Now let's see what happens here. Buff breaking. Okay, now it shows me an error that field 2 with name email ID on message user changed option JSON name from email to email ID. So it won't allow me to basically make the breaking change, or at least give me a warning. So that is there. So I hope this video was helpful to understand the current problems people face in schema management, why it is important, and how Buf and Protobuf can really help you. If you like this video, please don't forget to hit the like button, subscribe to the channel, and also please do not forget to check the links in the description. These are really important and I hope you learn from them. So thanks a lot for watching the video, and until next video.